Alright, moving on to worksheet B for chapter 3. So looking at just a couple of these guys. So number 1, so assume equal numbers on birthdays occur in each of the 12 months of the year. So probability that a person chosen at random has a birthday in March, so that must just mean 1 out of 12, because of this statement right here. So they were just trying to tell us not to account that certain months have different numbers of days. So they're trying to say, like, basically pretend they all had 30 days or something like that. So that's where we're just getting the 1 out of 12 for this one. So 3 people are chosen at random. Explaining your methods, find the probability that all 3 have birthdays in March. So for this one right here, if we had 3 people chosen at random, that simply means that the first one is in March, which would be 1 out of 12. It also means the second one is in March, which is another 1 out of 12, and another 1 out of 12 for the third person. Or if you wanted to, you could write that as 1/12 to the third power. Same thing. So what about the fact that none of them have a birthday in March? So, the easiest way of looking at that would just simply be to consider those cases the same way we took to figure out that answer. So if it's not in March, that means there's 11 out of 12 that it's not in March for the first person, 11 out of 12 for the second person, and 11 out of 12 for the third person. So just not March, and not March. So we're just looking at the complement to these guys right here. So that's as far as we're going on problem 1. So now we're jumping down to problem 2. So looking at parts A and B. Alright, so we're given 3 bags. So some yellow, some red, bag A. So it goes on to give us all the description for the bags. So a trial consists of choosing a bag. So that's the first thing we got to recognize. Is the first thing we're doing is just choosing a bag. So that's like the first event that is taking place. It's just picking a bag to choose from. And then drawing 1 marble at random and noting its color, then replacing it, which is super important to note that we're putting it back, which means the second event will not be affected by this event, or the next event would not be affected by this event. So we're going to just talk about a tree diagram indicating probabilities on each branch. So first set of branches on our tree diagram would just be the first event, which is just where we are choosing a bag. And so because it gave us this statement right here, they made this the first event. One thing you got to consider is if this were not an option, like if they didn't say a bag was chosen at random, it could just be that the drawing the marble is the first event. But because of this statement right here that we're actually choosing a bag first, makes that the first event. So it could be bag A or B or C. So we first got to choose a bag. And would probably be 1 out of 3 for each case, but they give us some other probabilities down here. So they're saying that A is a third. Then they're saying that bag B is 1/6 and C is 1/2. So they're giving us those for the bags that are being chosen. And then they're talking about choosing a marble and replacing it. Looks like we're only picking 1 marble. So this statement sort of becomes irrelevant if we're only going to pick 1 marble. It really wouldn't matter if we're replacing it or not if we're only picking 1. But anyway, so from here, if we look at bag A and use that information, so there were 3 red and 2 yellow, which must mean it could either be red or yellow. And there were 5 total. 3 of those 5 are red. The other 2 out of the 5 were yellow. Moving on to bag B, there's 1 red and 3 yellow. So 1 of the 4 are red. And the other 3 out of the 4, I'm running out of room, are yellow. And then last one here for bag C. Bag C, we had 2 red, 1 yellow, so 2 out of the 3 are red. And the other is yellow. So there we go. So we got our tree diagram. Typically what you often see with quick questions like this is when they give you a statement like that, it's because you're then picking another marble. And so we then have to consider what would happen on those remaining cases, but this one didn't go that far. So now it says find the probability that on any given trial a red marble is drawn. So, and then give correct to 3 sig figs. Remember, on a test, we always do 3 sig figs or exact unless the directions say otherwise. In this case, they specifically want 3 sig figs, so that's what we would do. So now we're just looking at the red cases. And so if I looked at it came from bag A and was red, so I'm going to multiply those together and get 3/15. So there's one case where I have a red. My other red case was the bag B and red. So if I multiply those, I get 1/24. And then from bag C, if it was red, a half times 2/3 will give me 2/6. And so those are the 3 red cases. So just add those together, and you have part B. And then just throw that into your calculator so you can get that answer to 3 sig figs. Let's just look at the last one here for part C. So given that the marble that was drawn is red, find the probability that it came from bag C. This one's worth taking a look at, so for sure. So remember how we set these up is we put the given on bottom and we put the and statement on top. So we're saying what's the probability that it came from bag C given that it was red. So the way we always want to set these up is we put the and statement on top. So bag C and red out of the given, which was red. And so one thing that helps is we already know the denominator. We figured that out up here. So when we added those 3 cases together, the red cases, that now is the denominator for part C. And so that answer goes right here. Cases that came from bag C and red were this guy. So that would be our numerator. So you got the 2 out of 6 for him. And then if you add those 3 cases, our answer from part B looks like was 23 out of 40. That would be our denominator because that was the total probability that it was red.